working off page 104 tonight, lads. And what we're trying to do here is we're trying to find the true angle the oblique plane makes to the horizontal plane. So the methods that we're going to use is using the cone method here. And by using a cone, what we're doing is we're placing a semi-cone underneath the oblique plane. And then we rotate the side of the cone so that our line of vision is meeting that at an angle of 90 degrees in the elevation, so we get the true angle that the oblique plane makes to the horizontal plane. So if you look over here, we have our semi-cone. This is the pictorial version, and you can see that here we have one side of the cone. It's in contact here with the horizontal plane, and it would be in contact with the oblique plane all along that line. So if you rotate that triangle so that it's now on the vertical plane in elevation, now you will see the true angle between the horizontal plane and the oblique plane. So how we do this question, it's very, very simple. Anywhere at all, you drop down a height line, and then where that height line intersects the XY line, we bring a line onto the horizontal trace at an angle of 90 degrees. Now that gives you the point, the center point of your cone. So you put the point of your compass there and you open up the compass to where that line intersects the horizontal trace, and we draw the base of the cone. Now you have to realize that this line, the plane is lying against the cone all the way up along that line to its top, and its top is directly on the vertical trace. So our oblique plane is in contact with the cone all along that line. So when the base of the cone is now rotated into this position here, any line that's joined from the base of the cone up to the apex of the cone will always make the same angle to the horizontal plane. So by bringing this in here, that gives us now the true angle that the oblique plane is making to the horizontal plane. So I'll say that again: drop down your height, bring a line onto the horizontal trace at an angle of 90 degrees. At an angle of 90 degrees. That gives you the radius. Point of the compass there, open it out to that, draw a semicircle. Where the semicircle intersects the XY line, join that up to the apex of the cone, and this gives you the base angle here. Now over here, I want you to make a quick little sketch of that. So it says there to come in 13 millimeters to get the T point where the traces meet, come in 20 millimeters to get that point there, and come in 23 here. And this line on the bottom will be parallel to that line at the top, and the vertical trace will be parallel to that, and then place the cone underneath it and write in the information on the drawing. So moving on to the second question here. It says there, given are the traces of an oblique plane, find the plane's true inclination to the vertical plane using the semi-cone method. Draw the oblique plane within the planes of reference provided and illustrate how the semi-cone can be used to find the true inclination of the oblique plane. So this time we're looking for the true angle between the oblique plane and the vertical plane. So this time we have to draw the cone in a different orientation. So the cone is lying flat along the horizontal plane. So to do this, anywhere at all, we draw a line that comes straight in from the horizontal trace into the XY line. Where it intersects the XY line, we bring a line onto that at an angle of 90 degrees onto the vertical trace. Again, that point there is the center of your cone, and this is the radius. You draw the semicircle. And where the semicircle intersects the XY line, we draw that back up to the horizontal trace where the apex of the cone is. And then this angle here is the true angle between the oblique plane and the vertical plane. So you can see that there, this time we have our triangle butting up against the oblique plane here. And when that's rotated down onto the flat in plan, you see the true angle between the oblique plane and the vertical plane. So simple enough, line from the horizontal trace into the XY line, 90 degrees to the vertical trace, that gives you the radius, point to the compass there, draw a semicircle, and then join that back to the horizontal trace to get the angle, the true angle. Question 3. Given are the traces of an oblique plane, find the plane's true inclination to the horizontal plane using the auxiliary method. Now, we have already done this when we were looking at solids cut by an oblique plane and you want to get an edge view of the plane. That edge view is going to give you the true angle between the horizontal plane and the oblique plane here. So again, if you're looking for the true angle between the oblique plane and the horizontal plane, you have to project from plan. So we extend on the horizontal trace from plan. Anywhere in elevation, we drop down a random height line, and where that intersects the XY line, you bring that up into your auxiliary elevation. The oblique plane is going to disappear into the horizontal plane along the horizontal trace. So that's a point view of the horizontal trace there. Then we take our height from the elevation and we mark it up there, and that gives us the edge view of the oblique plane. And the angle in here then is the true angle between the oblique plane and the horizontal plane. So remember, in an auxiliary elevation, the XY line is an edge view of the horizontal plane. There's the edge view of the oblique plane, and then that gives us the true angle between them. And finally, question 4. Given are the traces of an oblique plane, find the plane's true inclination to the vertical plane using the auxiliary method. So again, if we want to find the true inclination of a plane to the vertical plane, you see an edge view of the vertical plane in plan. So we go up to the elevation where we have the vertical trace, and we look along the vertical trace and extend it down here. You set up your XY line at 90 degrees to that line, and this time we take a random width in plan. We bring in this width, and then where that cuts the XY line, we bring that down there, and then from the X1, Y1 line, we mark that distance up along here to get the edge view of the oblique plane. So all of that completes the drawing. Put the effort in and put in all the relevant writing and information. Put a lot of effort into those diagrams that show the three-dimensional views, and use colour to highlight the important lines. Complete that sheet for Monday. Thanks.